Hello to everyone. Today we are going to talk about simple linear regression. And you know that regression it is the central term in econometric, and that's why today in laboratory work number 2 we will talk about how to create a simple linear regression model, what we need to do, what kind of steps we need to do, and also how we can investigate of its adequacy to all statistical data which we use to define our regression model and build regression line. So first of all, we will begin from some theoretical information, and I want to remind you the most important equation, and in this case the first equation which you can see, it is equation which describe the regression simple regression model, and where y it is our observed or actual value of dependent variable, a0 a1 it is unknown parameters which we must to estimate, x it is our independent variable, and if we talk about simple linear regression model, it means that only one factor, only one independent variable we include into our model. You can see that it is only one, x, and also we always include unobserved factors or residuals into our model because we remember that all our econometric model must be stochastic. So, and also in regression, we need to study the stochastic type of relationship, not functional, but stochastic. And that's why we include this factor, this component into each R model. So then we need also to recall that simple regression model we can divide by two parts, and first part it is systematic part, and we can define it by using this kind of equation where we use another symbol to underline the differences between actual value or observed value of dependent variable and its predicted or estimated value of dependent variable. And you can see that this systematic part we also sometimes called population regression function, in short PRF. And if we want to define and to build the simple linear regression model, what we need to do? We need to find, first of all, this simple population regression function, PRF. We need to estimate our unknown parameters, and we need to put also our unobserved factors. So first of all, we need to estimate, to build PRF, to estimate our unknown parameters. How we can do it? By using the fundamental methods of in mathematics. It is least square method, or in short OLS. So OLS method based on the one important criteria which we use to define our unknown parameters, and this criteria it is minimization the sum of squared the differences between our actual value of y and our estimated value of y, between our actual value and estimated value y and our y hat. In another way, we can call the differences by our unobserved factors, and you can see that we in another way can define u like these differences between y and estimated value of y. So in other words, we can say that the criterion of finding our unknown parameters a1 and a0, it is minimization, sum of square of differences between our actual and estimated value of y, or in other words, sum of square of our unobserved factors u. So how we can, when we will solve and find these parameters, we in the end will be able to find a system of normal equation, and by putting some statistical information about sum of x's, sum of y, and by knowing the number of all our observation n, we can write the system of normal equation, and in this way, in handle way, we can find the value of our unknown parameters a0 and a1. But we also can find these values in another way by using matrix and vector form, and in this case we need to use another formulas. It is formula 2.6, where we use in matrix form our matrix of x, of our independent variable, into this form, and we put into all first our column each element which is equal 1. Why? Because if you can see, when we talk about our simple regression function, you can see that mathematically you have two unknown parameters, but only one parameter which you know information about it. So that's why mathematically it means that you need to put near to your first, so empty first parameters, you need to put x which is equal 1, and it doesn't change the function, this equation, but it will be right mathematically if we want to use a matrix approach to find unknown parameters. That's why we always, when we talk about this formula, we use matrix X and put all elements of first column which is equal 1. Then we need to use a transpose matrix of X, and for this reason, we will use special formulas into Excel, because all our laboratory works we do into Excel. Then we need to inverse the multiplication between these two matrices, and then we need to multiply it by, again, transpose matrix of X, and then by vector of our dependent variable Y. And all these formulas from 2.1 to 2.6 describe the probably about the most important and the first step in our regression analysis, which can help us to fit in the regression line to estimate our regression function. So when we will find unknown parameters, we will be able to go to the second step. And second step, it is to use a complex of statistical indicators like simple correlation coefficient, determination coefficient, and also Fisher's criterion. For what reason? To verify our model. If our model is adequacy to all statistical database which we use to build the simple regression function. So we need to verify our model and find the answer. If we are able to use this model with high level of probability to make prediction. And if we will find that our model is adequate, it means that we go to the next step, and next step it is building the prediction of our dependent variable y according to our simple regression function. And for this reason we will use the equation 2.10, but also we are able to find confidence interval of this value, predicted value of y, and for this reason we will use equation or formulas from 2.11 to 2.13. And also in this laboratory work we will find coefficient of elasticity, and for this reason we will use equation 2.14. So if we sum up all this theoretical information, we can say that in this way we will able to solve all our tasks into this laboratory work. And you can see that we have 6 tasks. It is first one, it is creation the population regression function, and it means that for this reason we need to estimate our unknown parameters, and we do it by using ordinal least square method, OLS. Then we need testing the model by using correlation coefficient and determination coefficient, and also we need to test the significance of our model by using f-test. Then we need to find predictive value and confidence interval, determine the coefficient of elasticity at the forecast point, and in the end of all our calculations we also need to give a graphical interpretation of our model. So you can see that we have statistical data which give us information about how changes y our income of enterprise, and how changes our salary of expenses for salary. It is our independent variable x, and you can see that all our statistical data set consist of 15 observations and 16 values. It is our predicted value of independent variable x. So now we are ready to go to Excel file, and we will begin from the first our task, how we can create the population regression function PRF in Excel. So I change our screen and go to the Excel temples. So I will doing all my calculation by using first variant. And in this case, we can see that it is our statistical database about changes in y and x. We have 15 observations, and we need to find what? We need to find our simple regression function y estimated by using formulas a0 plus a1 multiplied by x. So for this reason, in this Excel file, we will use 3 approaches how we can do it, and we will start from the first matrix approach, and I put the necessary formula which we need to use, and according to these formulas you can see that we need to prepare some information in appropriate form about our independent variable x. We need to define matrix of x, we need to define transpose matrix of x. Also we need to use also a vector of dependent variable y. That's why if you look down you can see that we have our necessary components. We have x, and into this first column you remember that we need to put all elements which is equal 1, and the second column will be, we will put information from our statistical data set. It is all this observations about independent variable x we need to copy into second column of x, of matrix x. And for this reason, we need to use special insert and use values. Then we need to also fill our vector of y. And again, we use our data set and copy it into this column, and also we use special insert and values. Good. In this way, we are ready to go to the to find the next our component. It is transpose matrix of x. So to transpose matrix of x, what we need to do, we need to use copy of all elements of our matrix x, and then stand into the first cell and use special insert and element транспонировать, да? Transpose. And we can see that we change our columns by rows. So what we can see that our matrix in our laboratory work has a size 15 by 2. And when we want to transpose this matrix, it will be 2 by 15 size. And if we take a look at our formulas, first of all, what we need to do to find our unknown parameters, we need to define the multiplication between x, transpose matrix of x, and matrix of x. So you should remember from mathematics discipline that when we will multiply matrix with different sides, for in our case, when we will multiply the matrix with size of 15 by 2 on matrix 2 by 15, in the results we will get the matrix of the size 2 by 2. And that's why you can see that we have this size, and I mark it with gray color to your convenience. And if we want to multiply two matrices in Excel, for this reason we need to use function mmult or mumnoj in Russian or Ukrainian language. And we need to put first massive, it is our xt, good. Then put semicolon, and then we need to use our second massive, it is our matrix x. And then we need to insert Ctrl Shift Enter simultaneously. Good. Then we need to inverse this matrix according to these formulas. So for this reason we use function minverse or mobr in Russian version. And we fill our previous matrix, and again Ctrl Shift Enter. Then we need to multiply two matrices, inverse matrix by transpose matrix, and in this case we will get the matrix again with the size 2 by 15. And for this reason we again must fill all our matrix, all elements. And then if we want to multiply, again we use mumnoj. And our first massive, it will be our inverse matrix. We put a semicolon. And then the second massive, it is our xt, it is our transpose matrix of x. Then we close parentheses and Ctrl-Shift Enter. And now we can see that the last operation, it is to multiply the last hour or previous hour matrix by vector y. So for this reason, we again fill all our elements. It is our elements of unknown parameters a0 and a1. So if we multiply matrix with two different sizes, the first one 2 by 15 on 15 by 1, it means that in the end we will get the matrix 2 by 1. It is our matrix A. And again, for this reason, we use formulas mumnoj. And we use first massive, it is our previous matrix. We put semicolon, and also we use our vector y, close parentheses, and Ctrl-Shift Enter. So in this not difficult way, we find our regression function y estimated, so y with head, and according to the equation of our sample regression function, we can put necessary values. So a0, it will be equal 5.6 or 5.7. We decrease, and 1.9 and 1.9. So now we know how to, in this way, we know how to use a matrix approach, how to use this equation to find the right values of our unknown parameters by using ordinal least squares. But there are another way how we can define it, and the second our way, our second approach will be based on the solving the system of normal equation. And for this reason, you just need to find the sum of x, sum of y, sum of squared rx's, and the sum of multiplication between y and x. And it is your homework. You need just put all this necessary information, and then in handle way, for example, on the paper, find your A0 and A1 and check if is it correct and if it is the same values that we find by using our first approach, matrix approach, based on using OLS method. So it is your homework and you do it by itself. What according to our third approach? According to our third approach, we also based on the system of a normal equation, but we transform it into, again, matrix form. And if we transform it, this system of normal equation into matrix form, we can write the equation that A, our vector of unknown parameters, must be multiplied by x, where x it will be matrix with element n, sum of x, and sum squared x, and all this multiplication must be equal y, whereas y it is vector of two elements, sum of y and sum of multiplication between y and x. And from this point of view, by using this equation, we can define that our A, it will be equal inverse matrix of x which we should to multiply by vector y. So for this reason, we need to define the unknown parameters using this matrix, second matrix approach by using our system of normal equation. And for this reason, we need to put necessary information into this place. So first of all, we need to create matrix X with such elements. So what we need to do, we need to put to this cells the necessary information. So n, what does it mean n? N, it is number of observation. We have 15 observation. Then we need to put sum of x's, whereas our sum of x's, we can define it write down of our all information about observation about independent variable x, and the sum is equal 84.08. So we need just put this values into the second cell. Then sum of x, it is the same like diagonal element, and then we also need to find the sum of squared x. So for this reason, we need to probably I will delete this formulas. So what we need to do, we need to just take necessary value and times itself. So for this reason, we match the first value, then and then we need to strength down, and in the end we can find the sum of all these values, and it will correspond with the cell of our matrix, with the second cell of our matrix X. And then we need to find two elements of vector y, and the first one, it is sum of y, and we can take this value from table of inputs. It is our sum of all our 15 values of dependent variable y, which is equal to 246.54. And then we also need to define the sum of multiplication between x and y. And for this reason, we go to this column and just put a multiplication between these variables. Then we again strength down and find in the end the sum of all this multiplication, and put these values into our last element of vector y. Then, according to our formulas, I also put this formula in here. You can see that we need to inverse to find the inverse matrix of our matrix X, and you can see that we need to find it into this place. For this reason, we again need to fill all elements of this inverse matrix. It is a matrix which will also have the size 2 by 2, because we just inverse the matrix X with size 2 by 2. And if you want to inverse, we use function inverse or mobber from the massive X, and Ctrl Shift Enter. And the last our step, it is to multiply the inverse matrix by vector y. And for this reason, we use mmult, function mmult or mumnoj. And first massive, it is our inverse matrix. Then we put, need to use semicolon. And then we take our vector y and Ctrl-Shift-Enter. And in this way, we have the same our coefficients or the same unknown parameters which help us to define our sample regression function, our y estimated. And we can again write it by using first of all a0, then plus a1 by x. It will be our simple regression function which correspond with the same kind of view which we get when we apply a matrix approach. So the last and probably the most easy way how we can define our unknown parameters, and for this reason we can use one of Excel function. It is using function linest or linear, and in this way we can find these parameters in very quickly way. And also sometimes we can avoid so probably more complicated calculations and just using the function linest, and it is also very useful and very quickly way to find the right values of our unknown parameters. But you can see that when we talk about our previous methods of research, we use the order of our A elements, A0 then A1. But remember that when we will find these parameters by using function linest, we change the ordering of our unknown parameters, and the first it will be A1 and then A0. So just remember about it. And now what we need to do, we need to fill again two cells, then we need to use linest or linear. And what you can see that we need to, at first our massive, we need to put our values of dependent variable y, and we take all these values from inputs, from the table with our inputs. Then we need to put again semicolon. Then we need to take our values of x. Also, we need to fill all our 15 observation about x. Then we again put semicolon, and then you can see that we have two components, constant and statistics. And for this reason, in Russian, we just write istina, but if you use English language, for this reason, you use true, istina, true. So instead of istina, in English version, you use istina, true. Again, in the end of all this operations, you need to insert Ctrl-Shift-Enter simultaneously, and in the end you can define the unknown parameters, and you can see that it is the same value like into your the previous way of calculations. So it is all these methods which we described can help to create our simple regression function, and in other words, it means that we build the regression model, and the second very important stage or step in our regression analysis, it is to verify this function and understand if this model is adequate to statistical our data set, or in other words, it means that we need to find the question if we can build reliable prediction by using this model.
So, if we want to verify our regression model, we need to use a complex of statistical indicators. And first of all, we will use the sample correlation coefficients. It is the measure of the strengths relationship between x and y, and this kind of coefficient can help us to understand the linear connection between x and I, only linear kind of connection. And in other words, this kind of coefficient can give us information about is our x variable has really strong impact on our variable y. So if we want to do some conclusions by using the sample correlation coefficient, we should recall that this correlation coefficients lie in the limits or has the limits from -1, so -1 to +1, and if this coefficient is close to positive or -1, it means that we talk about a close and very strong relationship between x and y. And opposite situation when the value of this coefficient is close to 0, and in this case we talk about that there is no strong connection between x and y, and it means that x hasn't impact on y.
So to find sample correlation coefficients, we need to use some big formula, and this formula you can see in this place. So we will use the second part of these formulas, and in the numerator you can see that we need to find two parentheses of two differences between actual value of x and mean value of x, and between actual value of y and mean value of y, and then we need to find the sum of multiplications of these two differences. So for this reason, first of all, we need to define the first differences and then the second differences. So for this reason, what we need to do, first of all, we need to find, for example, mean value of x. How we can do it? By divided sum of x by all our number of observations. So we can put the formulas, or we can use average function or сравнать in Excel, and I prefer to use this kind of way. If you use English version of Excel, average, but I use сравнать because I use Russian version. So сравнать from the massive or x, and we just insert enter, and we have the same value. In the same way, we can find mean value of y. So again, you use average, but I'm use сравнать. Okay, and now what we need to do, we need to define the first differences between each our actual value of x and mean value of x. So for this reason, we need to subtract from this value our mean value. And if you want to to get all calculations in more quickly way, you can just fix our mean value, because it is some fixed indicator which will subtracting from our different kind of observation around x. That's why if you put F4 with sign of dollars, you can just strengthen the first value, and in this way you can define all 15 numbers of your first differences. In the same way, we repeat the actions if you want to define the second R differences between actual value of y and its main value. And for this reason, do not forget to also use F4 to fix our mean value. And okay, and in the end, you can find the sum of these differences, and it's some very important information, because when all our differences, all our different observation of some indicators around the mean value is equal 0, it means that we talk about normal distribution, and in this case we can use our ordinary square method and use all assumptions which give us the possibility to create a reliable regression model. That's why when you can see that your sum of differences according to x and y is equal 0, it is very good, and it means that all your calculations will be right into your laboratory work. And now we can take a look at the next part of your formulas of sample correlation coefficient, where you can define that we need to find the square of our previous differences according x and y, which has need to take into the square. And for this reason, you can see that we have two extra columns in this place. So what we need to do, we need to just write formula, and we need to do it for two kind of differences, and then we can fill this first elements of two differences and strengths down. Good. But when you take a look at this again, at the second part of our sample correlation coefficient, you can see that in the numerator, we talk about multiplication between two difference between x and y, and that's why it means that we need first of all multiply these two differences and then find the sum of this multiplication. That's why we have the last R column to calculate sample correlation coefficients here. And what we need to do, we need to do multiply this value by this value, and again strength down. Good. And then in the last R line, we find the sum of all our 15 values. So now we have all necessary components, and we can define our sample correlation coefficients, and I will do it into this place. So what we need to do, using these formulas, we can see that we need to put the sum of multiplication of two differences. We can find it into this column, it is this value, and we should divide it by what? Square root, and for this reason we need to use, for example, again, function in Excel. In Russian language, it will be korень, but in English version, it will be squared, S-Q-U-R-T. And from what value? From the sum of multiplication to squared differences. So for first one is our square sum of differences between x, y minus min x, and then we need to multiply it by sum of squared differences from y, and we close parentheses and enter. So in this way we define our coefficient of correlation, which is near to 1, and it means that between our x and y presents a strong linear connection or strong linear relationship, and it's very good for our model. We talk about positive correlation, not negative but positive, because our coefficient of correlation in this, according to our statistical data set, is positive. So what does it mean, positive correlation? It characterizes the positive regression between x and y. It means that if our x will increase, our y also will increase. In negative case, we will be make another conclusion. It means that when x will increase, our y will decrease. So in this laboratory work, we talk about positive relation between our expenses for salary and the income of our enterprises. Also, we can check if all our calculations are correct by using very simply function in Excel, Corel. And for this reason, we need to use first massive. It doesn't matter the ordering of putting the right massive. So the first in this table is massive about y variable. Then we put semicolon and take the second r massive. Between this kind of massive, we need to define the presenting of the linear relationship, and just enter. And you can see it is probably, we can write that it is checking of coefficient correlation, sample correlation coefficient, and they are both the same. That means that everything we do in right way. So next statistical indicator, which is very important to understand if we can use our regression model to create reliable prediction. It is coefficient of determination, and sometimes we call this coefficient like a measure of goodness of fit. It means that this measure tells us about how well the sample regression model, and if we graphically represent or illustrate this model, it will be some regression line. So this measure tells us about how well the sample regression line fits the data set. And that's why we have you can see the equation, and using this equation we can define the again two parts, two important and necessary components to define the correct value of this measure. So you can see the in the numerator it is the sum of square differences between two types of dependent variables. So between our estimated value, and this estimated value we will take from our simple regression function from this row or from this row or from this line. Yes, it is y estimated or y with head. And mean value we have. And in the denominator, we have another differences between our actual value, y without head. It is our observations around y. And again, mean value of y. And from the lecture, you know that we have some names of these differences. And if we talk about numerator, between differences between estimated and mean value of y, it is our explained sum of squares by regression, which we can explain by using our regression model, and we call it SSR, so or variation of our estimated value. And in the denominator, you can see the differences between actual value and mean value. It is our total sum of squares, SST. It is a variation of the estimated value of y about their mean value. So that's why if we take a look at this formula, we can understand that first of all we need to define the first differences, and then we need to define the second. So to define first differences, we need to find the estimated value. You can see that this symbol has index y, and it means that we use for y each kind of our observations. So we need to find such y estimated values that correspond with the number of our observations. So how we can do it? By using our equation of estimated value of y. So we can, for example, use this kind of place where we extract our necessary information. So our estimated value of y, it is our a0 plus a1 by x, and that's why we go to the first r cell, and what we need to put? We need to put a0 plus a1 and multiply by x. Again, when we talk about x, in this case, we talk about some vector of x or matrix of x. But when we talk about x with corresponding to each observation, it means that we will have such number of x such we have a number of observations. So it means that each RA1 we need to multiply by each kind of our axis according to number of observations. So if you want to define y 1 for the first observation, it means that we need to multiply a1 by x1. Then we need to do the same again, a0 plus a1 and multiply not first but at second 2x2 according to observation number 2. And in the same way we can repeat all these actions according to all our 15 observations. But of course we can just simplificate this process by, for example, fix it our constant value of a0 and a1, which will be repeated by 15 times. So we put f4, and then just we will be able to strength down and find the sum of all this, our estimated value of y. What we need to do next? We need to define differences between estimated value and mean value. For this reason, from this previous R value, we must extract mean value and fix it, because we will do it 15 times and we will subtract the same value. Then we need to put it into the square and again strength down and find the sum of our square differences. Good. So in this way we calculated our numerator. Now we need to define our denominator. And for this reason, if you will be careful with all our calculations, you can find that this kind of component we have already calculated, and these differences we can find into this column. And we need to find, to put into our formulas of coefficient of determination this kind of value. So we go to our place where we define coefficient of determination by dividing this kind of value by this. So now we can explain what does it mean, these values. So you know that the limits of the coefficient of determination are from 0 to 1, and if our coefficient of determination is near to 1, it means that our regression model or our regression line is fitting to the statistical data, and it means there is
present strong relationship between our y estimated and actual value of I, or in other words, between our regression line, all values which lie on the regression line, and all our actual value which we extract from our statistical database.
And if we want to check our calculations, we can know some dependence between sample correlation coefficient and coefficient of determination. For this reason, we just need to find the square root of sample correlation coefficient, and if a value will be equal to our coefficient of determination, it means that all what we did are correct. And the last statistical indicator which we need to find into this laboratory work, and that is the classical statistical indicator which help us to make conclusion, can we use our regression model for prediction is f-test and or criterion Fisher. So it is the last step for the linear regression correlation analysis, and we name it testing of significance. So what means this significance? It means that we can statement that our dependent variable y is influenced by x with some level of probability, and with the same level of probability our regression model fitted to the data using a least square method. So to make a right conclusion, when we use f-test, we need to compare two indicators. We need to compare estimated f-test by using our data set and with f-table, with table value of this criterion, which we can extract from some statistical tables with a different level of probability. In this laboratory work, we use 0.95 level of probability, or 5% of probability, and use such formula. So again, you can see two components of this, and first component, it is your numerator, and we need to use into this place the differences between estimated value and mean value, and we have this differences, the sum of square of these differences in this place. Then we need to divide it by K1 and K1. So what does it mean K? K1 is equal M. M, it is our number of independent variable which include into our model. And if we take a look our regression model or sample regression function, it is the same because it's synonymous. You can see that we talk only about simple kind of regression. We talk about only one independent variable. That's why M in this place will be equal 1, and we just can write it in here. And K2, what does it mean K2? K2 is equal n minus m minus 1. And it is our number of observations. It equal 15. And then we need to subtract from this value K1, m, it is equal 1, and minus 1, it will equal 13. So when we take a look at the denominator, we can see that we need to find the differences between actual value of y and estimated value of y. And we didn't have these differences with previous table. That's why we need to calculate it. And then we need to define the sum square of this difference and divide by K2. So what we need to do, first of all, we need to define the differences between actual value and estimated value. In another words, according to our regression model, it is our U, it is our unobserved factors or residuals minus estimated value. And then we just strength down and find the sum. And then we need to define the square of this value. Again, strength the line. And in this way we defined. And now we can define estimated value of f by using this big formula. So for this reason, what we need to do, we need to divide first differences by K1 and we take into the parentheses, first parenthesis, and then this first parenthesis, which is our numerator, we need to divide by second parenthesis. It is our next differences, which we need to divide by K2, which is equal to 13. And we define this value. Then in your laboratory work, you can define that F table is equal 4.67, but also we can check if this value is right, and for this reason in Excel we also can some function which can help us to do it. So for this reason you need to use in English version this function and in Russian this function. So what we need to do, we need to define this function, and then what we need to put, we need to use the level of probability, and in our laboratory work it is equal 0.5, then we use semicolon, then the first degree of freedom, first it is equal K1, and second degree of freedom it is 13. Probably I need to use comma. Oh, comma, good. Okay, so we define this table value of F, and if you read carefully your guideline, and if you listen to my lecture about explanation of this criterion, you should remember that if our estimated value is bigger than F table, it means that our regression model is significant. So by using all our conclusions, which we extract from calculating the coefficient, sample correlation coefficient determination, and F criterion, we can say that our regression line, our regression function, which we built into this place, is really reliable to make prediction. And we go to our next task into this laboratory work, how to make the prediction of our dependent variable y according to our regression model. And also we will be able not to only define the predictive value of y, but also we'll get to know how to build the confidence interval. And for this reason, we will use these formulas. So first of all, we need to find our predicted value of y. How we can do it? By putting necessary component into these places. So first of all, we need to put a0. We take this value from this place. Then a1. And then according to our laboratory work, we need to find predicted value of y in the point of predicted value of x. That's why we need to put into this place our predicted value of x. It is equal to 8.13, and I mark it by another color, green color, to attract your attention. Now we just need to put all this information into this formula. So we need to a0 plus a1 multiplied by predicted value of x. So what does it mean? What is economical interpretation? It means that if our expenses on salary will be equal 8.13, we can assume with
level of probability which is equal 95% or 0.95.
that our income, because we talk about why it is our income of enterprises, will equal 21.28. But in most cases, when we talk about prediction, we talk about that it is our base to provide some managerial decisions. So if we talk about managers, um, in most cases, they are concerned not about uh, this exactly value of some dependent variable of, for example, for income, if we will know the predicted value of our salary, because in most cases they also need to have information about the limits where we can suppose that our predicted value of dependent variable can be presented with some level of probability. That's why we can define what is confidence intervals. It is intervals in which the actual value of dependent variable enters a given probability. And for this reason, we need to use three type of formulas, and the first one represent.
The necessary component is delta.
To define this data, we need to know table value of t statistic, and then we for this reason will use some function in Excel to define this value, then multiply it by sigma of our residuals, and you can see that the third formula represents how we can define it. It is square root of dividing the sum of square differences between actual value of y and y estimated divided by n minus m minus 1, or another word, it's our K2. And then we need to multiply it by square root of this equation. So for this reason, to find delta, we will define the most important components, and we start from t-table value, and for this reason in Russian language you use Excel function stud распобор. In English version we use tinv function. So I use stud распобор, and you can see that we need to put our level of probability. It is our 0.05. Then put semicolon and degrees of freedom. In this case, we need to use n minus m. It is our n minus m. M is equal 1 because we have only one x included into our regression model. That's why we can put 15 minus 1 and enter. So our table value, which we need to use into our big formulas, we have already found. Next component, it is G residuals. It is our this formula. So if you remember, we have already found the differences between actual and estimated value of y. And where is this differences? It is these differences. A sum of a square is equal 18.26. And what we need to do, we need to take a square root and then divide it by n minus m minus 1 or K2. So for this reason, we need to use squaring or square root in English. from this value, which we must divide by K2. And the last one, we need to define this big equation and also take a square root. So again, korень from what? 1 plus 1 divided by n, and it is our number of observations, 15. Next, plus what? In the numerator, it should be the difference between predicted value of x, it is our predicted value of x, minus mean value of x, mean value of x, and we need to and then what we need to do, we need to probably to make new parentheses and divide by sum of differences xy minus a mean value of x. Where is it? It is our this value. That's all. Yes. So in this way we define this complicated component, and now what we need to do to define this delta, just multiplicate all our three components by itself. It will be our delta. We need to multiply this one by this one by this one. Good. And when we want to build the confidence interval, it means that in the middle of our interval we put our predicted value of y, and then we need to subtract from this value delta, and then plus our predicted value are again delta. So how we can explain economically? It means that with probability of 95%, our predicted value of y, where when x will be equal 8.13, will be lie in the interval from 18.5 to 24.1 billions of yuan. And our next task is to determine the coefficient of elasticity at the forecast point. Forecast point, it is our predicted value of y and predicted value of x. And for this reason, we need to use this formula. And what does it mean? It is partial derivation of our function y, our regression function, by x. And mathematically, it means that according to our function, a0 plus a1 by x, it means that it will be equal to a1. So it means that we need to just take a1 and multiply it by predicted value of x, which we must to divide by predicted value of y. And what does it mean, this coefficient of elasticity? It shows us how much the indicator, so our predicted value of y, will change if our x will change by 1%. So it will change by 0.73%. So if our salary will expense by 1%, our y will increase by 0.73%. And now we can finish our laboratory work number 2 by graphically represent or interpret all are the most important values. And for this reason, what we need to do, we need to go to our insert element in Excel. So we choose this kind of graph, then we need to choose the right information. We need to build two lines, and first line it will be y estimated value, or probably first it will be actual value, and for this reason x it is our salary expenses, and y actual it is our observations around y from data set, and the second line it will be y estimated, which we estimated, which we defined by using our regression model. So x it will be the same x, but y it will be find from this kind of column when we use these values by using our unknown parameters. And that's all. In this way, we can see probably we need to add some elements, probably legend in the down of all our the main graph, and through our all estimated values, so we can draw our line. And for this reason, what we need to do, we need to probably use this. Oh, yes. This kind of function in Excel, and you can see that all value that lie on this regression line, it is our estimated value of y, and all values around this line, it is our actual value of y, and the differences between each kind of our actual and estimated value, it is our unobserved factors, and all these residuals we try to minimize by using OLS, and thankful to using this kind of method, we define the best line, the best regression line, which lie on the minimum distance between our statistical data and all our estimated value of y. So it is the end of all our calculations. So in this way we can make conclusions, and the first one, we know how to create regression function. For this reason we use OLS method and three approaches: matrix approach by using this formula, matrix approach by using this formula. Also we can solve the system of normal equation, and also we know that there is some easy way to define our unknown parameters by using function xaliened. Then we know how to define three statistical indicators which help us understand if our regression model is reliable, is significant, is adequate to the statistical data set. And in this laboratory work, it is really true. We can use this model to make prediction of our dependent variable, and we did it by using these formulas. Then we also created the confidence interval of this predicted value of y, and also we define the coefficient of elasticity, which can help us understand in what way our y will react by changing on one person in x. And in the end, we've drawn mm, our the most important uh, graphical plot which describe the connection between x and y, whereas x it is salary expenses and y it is our income. And we can see this regression line which describes this connection and which is adequate to the statistical data set which lie around this line on the minimum distance of our all regression values of y or y estimated. Thank you for your attention.